Good day, everyone. My name is Li Maoqi. I'm come from University Malaysia Pahang. Thanks for second International Postgraduate Conference on Mechanical Engineering inviting me to join the conference. Today I'm going to present my paper, which title is Investigation on Linear and Nonlinear Dynamic Equation for Vehicle Model in Numerical Simulation. The vehicles are the very important transportation that we often use it in our daily lives. So the traffic accidents are inevitable. According to the latest data released by the Department of Statistics Malaysia, which is DOSM, in October 2019, a total of the 168,168 people and 172,031 people died between 2017 and 2018. Among them, the number of the deaths due to the traffic accident in these 2 years is about 4.6% and 3.7%. It's about 6 to 7,000 people died just due to the traffic accident. So it is very important to improve the safety performance of the vehicle. Let's see the right picture. There's three cars hit each other, and there's some piece of the vehicle just out of the vehicle, and it's totally cannot drive, and it also might injure the driver. So it should be have the more better safety performance of the vehicle are improve the safety performance. Okay, next is about problem statement. First, I have mentioned that it is very important to improve the safety performance of the vehicle. Then how to improve the safety performance? Yeah, it's test. Let's see these three pictures. This all the real car testing for test the safety performance. We can see that the driver is just a mode. This is not the real people's. And also can see the car from the point, and the car also become the scrapped car after one-time testing. And we can see that this kind of testing, this is very expensive and it's very dangerous. Like even you just using the model without the real people, but the small piece of the vehicle may be just spread out, and it is still very dangerous. And after one-time testing, you cannot test second times. So all the car become a scrapped car. So can we find different testing? It's not expensive and it's more safety. Here is a solution: the numerical simulation. The simulation is very safety because it's using the software. The software, you can use it in your PC, in your laptop, and it is more cheaper. If you just do the experimental for the real car, then the real car just do it once, it will become the scrapped car. But the simulation, no. You can do it many times, just do whatever you want to do the times. For the simulation, you need to build a simulation block because the software that I'm choosing is MatLab Simulink. For the simulation block, I choose the vehicle dynamics equation as the simulation equation. The next is about research process. There's three stages of the research. the first stage is experimental. The experimental is doing the road testing using the real car with the different speeds by using the testing car, which testing car provided by University Malaysia. Let's see some picture for the experimental. The left one is a testing car, which is provided by AEC UMP, and the right one is a UMP roundabout on the wide-angle lens. The middle one is during the experimental. The second stage is doing the simulation, which is using the parameter from the testing card to build the simulation block and do the simulation test. Let's see the left side. This is the constant value for the vehicle, and the right side, this is the simulation block. The upper is theta f, theta r, which is the steering angle. And the lower one, this is a nonlinear equation of motion, linear equation of motion, which is nonlinear equation and linear equation. The last stage is analysis, which is collect all the data from the experimental and also the simulation results. After that, compare them. This is a block diagram. Experimental provide the parameter to the simulation block and give the result. The numerical simulation, there's two nonlinear equation and linear equation, two types equation. Next is experimental results. This experimental I decided with three different speeds, which is 25 km per hour, 30 km per hour, and 35 km per hour. We can see that the upside is the speed 25, 30, 35, and with the real speed is different with the side speed, but it is during the experimental, so it's a bit different. The following is the yaw rate. The next is the linear equation result. The left is Vt chart, which is the speed and time. The right side is yaw t chart, which is the yaw moments and the time. The next is about nonlinear equation results. It's similar with the linear one. And after that, we can compare it. What is the difference between experimental, linear, and nonlinear? This is the UV chart by the three results, which is experimental, linear, the result from experimental, the result from linear, and from nonlinear. We can see that the blue line is the experimental line, which is start with 0.324, 0.329, 0.408, and the red line is a linear one. The linear one is we can see that this is the difference between the linear and experimental. It's more and more goes down, but the blue line, the experimental, is more with the speed increase is also increased. The green line is a nonlinear one. By comparing that, we can see the nonlinear is more better for the experimental. So, as a conclusion, with the speed increase, we can see that the linear result is more and more getting far away from the experimental result. But the nonlinear result is gradually rising with the speed increase. It is getting closer. So, we can see that the nonlinear equation can be used as the equation for the simulating the vehicle motion. That's all for my presentation. Thank you.